Welcome back. We are now in section 1.3. We just got done talking about all the things we can do with real numbers. So in this section, at least at the beginning, we're going to turn our focus into how do we turn English into math? Okay, that's something a lot of people struggle with. So in this video, every problem that we're dealing with is going to have a lot of words attached. They're essentially all word problems. But what this section really teaches you how to do is turn those words into the math that we can use the properties we know about to solve. So it's really kind of like word problem 101. We've already done some word problems in this class, but this really gets at the heart of what it means to take words and put them into math. Let me show you what I'm talking about. So for our first example here in the notes, do you have pencil and paper ready? It's a lot better if you do. Take these notes. We want to write an algebraic expression to represent the verbal expression 7 less than a number. That's a lot to digest. There might even be some words in there that you don't know. So let's take this gobbledygook, which is technically the English language, and turn it into a much better language, which is math. So, the phrase, an algebraic expression. Algebraic, you can see the word algebra right in there. So we want to write something about algebra, math, and it says an expression. An algebraic expression is math without an equal sign. Okay, so we are interpreting these words so that we can find out what they want us to do. So we want to write math without an equal sign to represent the verbal expression, the verbal expression being words. I'll actually start my brackets here after the word the, so it makes a complete sentence. Okay. So we want to write math without an equal sign to represent the words 7 less than a number. I think that was an important little bit of interpretation here. Now it's a little easier to see what we need to do. We need to turn the words 7 less than a number into math. How would we write that in math? Well, see, the problem is they don't tell us what the number is. If they said like 7 less than 3, that's a bad example. 7 less than 20, we might be able to give what the answer is. But we're not interested in what an answer is. We just want to turn this into math. How would it look like in math? And specifically in algebra, if we want to know, or if we want to represent a number but we don't know what the number is, what do we usually call it? Well, we use a letter, and the letter we use the most is x. So a number is going to be x. So we want to be able to write 7 less than x. 7 less than x. How do we write that? Well, I kind of already gave you a hint as to how you could write that. Let's suppose x is a particular number, like 20. How would you write 7 less than 20? Now, when I've done this example in the past, I saw something that I was shocked by when I first saw it, but I understand why people would do this. They write this. 7 less than 20. Because this is a less than sign. And technically, yes, that says 7 is less than 20. But this doesn't say 7 is less than 20. It just says 7 less than 20. So we're actually not going to use this less than sign, as nice as that would be. we want to write something else. So I'll give you a hint that less than here means we are subtracting. We are subtracting. So the only question is this 7 minus x, or is it x minus 7? Interesting. I know in this verbal expression, 7 comes first. But we're trying to figure out if this is 7 minus x or x minus 7. Let's replace x with a number, like 20. So this would be 7 minus 20, and this is 20 minus 7. What is 7 less than 20? What number is that? Well, 7 less than 20 is 13, right? So the right way to write this, if you do it, you should get 13. So which way is right? I'm kind of pointing to it right now. It's this one. So even though in the verbal expression, in these words, 7 comes before x, when you're dealing with less than or subtraction, it's actually reversed. 7 less than a number is x minus 7. It's not this. Okay? 7 less than a number is x minus 7. So that might be a little tricky. It was actually kind of evil of me to start with a subtraction problem, considering we just talked about the properties of real numbers for addition and multiplication. If this were 7 more than a number, it actually wouldn't have mattered, because 7 plus x and x plus 7 are the same. That's the commutative property of addition. If it were multiplication, it wouldn't have mattered which one's which. But since it was less than, and that means subtraction, the order does matter, so that's something you have to be mindful of if you see another example like this, or a homework problem or something. Okay. Let's move on to example 2. It's asking something similar. Write an algebraic expression to represent the verbal expression, and then we've got a new expression here. Now, the directions here are exactly the same as they were there. So if you want, you can say, write math, no equals sign, to represent the words. And these are the words that we are trying to write in math. The square of a number decreased by the product of 5 and the number. Now, the way I read that, I paused several times. And I think in these particular problems where you're turning words into math, it helps to break it into pieces. The square of a number. Let's stop there. The square of a number. That means like something squared, right? Like an exponent of 2. But the square of what number? It doesn't say what the number is. Just like it didn't here. We called it x. Let's call it x again. Because as mathematicians, we kind of lack imagination a little bit. We're always going to call that x if we have a choice. So how would we write the square of x? I know there are other words here. We'll get to those. How would you write the square of x? X squared. Okay, so this part we've knocked out. The square of a number. Boop. Decreased by. Decrease means to go down. The mathematical operation for that would be subtraction. Now this was less than. This is decreased by. Those are different phrases. They both mean subtraction. But if we're doing something decreased by something else, then that is going to be in the order that we see it. The x squared is going to come first, and the decreased by minus sign is going to come after it. Okay? I want you to think about the difference between this subtraction and this subtraction. Okay? If we had like 7 decreased by 2, that's 7 minus 2. But 7 less than 2 is 2 minus 7. So it is backwards. So the square of a number is x squared, decreased by is minus. Okay, so I'll actually so the square of a number, x squared, decreased by is minus. The product of. The product of. Product means what mathematical operation? Multiplication. We're going to be multiplying whatever is here. What is it we're multiplying? 5 and the number. The number being the same number as this, which we called x. So we are multiplying, we're taking the product of 5 and x. What is the product of 5 and x? Well, if we multiply a number and a letter, we just squish them together, right? That's 5x. So, the square of a number decreased by the product of 5 in the number is just the way of saying x squared minus 5x, real fancy like. We can take these words and turn them into math without an equal sign. X squared minus 5x. So, that's a couple examples of how this type of problem works, where we're taking the words and turning them into math, one piece at a time. So, we've got 2 problems here, and generally the way it works in the notes that I create, by the way, I make all these notes myself. You'll not find them anywhere else in the world. I've created them on my own. I do the examples to be done together as a class. If we were in the classroom, I would be going through these just like I did in this video. The multiple choice questions are usually meant for you to do on your own. I would give you some time in class to work on them, and then when most everyone is finished, we would go over it after you've already done it. So, in the spirit of that, these 2 problems are very similar to these. You'll notice the directions are exactly the same. The only thing that's different is what the actual expression is that you're turning into math. So try these 2 problems out, see what you come up with, pause the video when you do that, come back when you've got them, and see how well you did. Alright, I'll trust you pause the video and try these. There's no penalty for getting it wrong this time. But if you wait until there is a penalty if you get it wrong to do it on your own, that's when it starts feeling unfair. So involving yourself as early in the process as possible, doing it on your own right now, is helpful. Even if you feel like you're getting everything wrong, it's still helping. It's still helping. So we are going to turn this into math. 6 more than a number. 6 more than a number. Well, oldest trick in the book, right? If it's a number and it doesn't tell us what it is, that's x. So, we've got 6 more than x. More than suggests what mathematical operation? Well, it sure as heck is not subtraction, right? Because that's less than. So if less than is subtraction, more than is addition. So we are adding 6 and x. Now, does it matter if it's 6 plus x or x plus 6? Does the order matter? It did with subtraction. The commutative property of addition states that these two things mean exactly the same thing. So either one is correct. Either one is correct. Neither one is more correct than the other. They are exactly the same. Technically, if I had to pick one, I would pick this one. Because it's like we have a number and then it's 6 more than that. So that kind of, it makes me feel like it's the number plus 6. But this is exactly the same, so it's right. Doesn't matter. Yay! Don't you love math? Sometimes there's more than one answer. It's great. The last example. Oh, so in the notes, x plus 6 is b. That's answer B. And since it was multiple choice, oops, it's not like you could have looked at it in this video because I didn't scroll down like I should have. Whoops. Here we go. You can essentially cheat and see, okay, which of these makes sense? And the only one that has a plus sign is B. So you could use process of elimination. That's a viable technique to answer these questions. The second one here, write an algebraic expression, represent a verbal expression. 2 less than the cube of a number. 2 less than the cube of a number. Okay. A number is x. Okay. This is getting old, but that's good, right? The more you see it, the more quickly you understand a number is x. So 2 less than the cube of x. 2 less than means subtraction, right? We saw that in the first example. Less than means subtraction. The cube of x is kind of like the square of x. But instead of a 2, cube in math means 3. So this is going to be x to the 3rd power. So we've got 2, we've got a minus sign, and we've got x to the 3rd power. What order is it? Is it 2 minus x to the 3rd, or is it x to the 3rd minus 2? We've seen this. Less than is going to work the same way it did here. If we had 7 less than x, it was x minus 7. So it's almost like whatever comes after less than is what goes first when you write it as math. It's going to work the same way here. We have 2 less than x to the 3rd power, so it's really x to the 3rd power minus 2. X to the 3rd power minus 2. And that, again, in your notes is answer A. And again, that's the only one that has subtraction and an exponent of 3. So you didn't have to think about whether it was x to the 3rd minus 2 or 2 minus x to the 3rd if you looked at the answer choices. But it's good to know that it's this way. So, I feel like we're having fun. We're taking word problems and turning them into math. What could possibly be better than that? I personally don't like words nearly as much as math, so turning words into math is really fun. For me, maybe it is for you. There are 2 more examples on the front page of the notes here, and I want to talk about those in this video. So give me a sec to clear this out, and we'll do those last 2 examples. Okay, our last 2 examples for today, unfortunately, have us going in the other direction. We've been taking English sentences and turning them into math. And I particularly enjoy going in that direction because I like turning things into math. But it's also useful to be able to take an algebraic expression, something that's already written in math, and turn it into words. It's not my favorite thing to do necessarily, but it is an important skill. So we've got a couple examples that we're going to be doing that. We've got mathematical expressions here that we're turning into words. And that's what this is telling us to do. Write a verbal sentence. The word verbal actually means like spoken. You can think of it that way. Write a verbal sentence to represent 6 equals negative 5 plus x. Now, if you're able to take this, what I just read, and verbalize it in words, that is good enough to answer this question. If you can say in words what this is saying, that is good. You can do that. So when I spoke this, I said 6 is equal to -5 plus, I said x, but in words, remember how in the problem it would always say a number when we wrote x? Let's turn that back to a number. Because in words, we don't want to take -5 plus x. X is standing for a number. So in English, it would look like that. 6 is equal to -5 plus a number. Is this the only possible answer? No, not even close. There are more possible answers this way. You don't have to write exactly this. You could write something like 6 is equal to the sum of -5 and a number. Okay, so instead of just saying -5 plus a number, you could say the sum of -5 and a number, because when you add two things together, it's a sum. This is probably more likely what you would see if you were starting with the words. I don't think they would write it this way. You could write "6 is the sum of -5 and a number." The great thing about the word is that it means is equal to. So you don't have to write is equal to. You can, it's correct, but this is neater. It's prettier. I dare say this sentence is sexier because it has fewer words in it and still says the same thing. Okay? So this would probably be my favorite answer of these three, but they're all correct. If I gave you a problem like this and you wrote any of these three things or something else that means the same thing that's correct, it's right. So I guess that's one redeeming thing about going from math to words, is that there are more ways to get it right. There really are. It's actually kind of hard to get it wrong. Okay? So this isn't a multiple choice question because I feel like that would take too much of the joy out of the problem if you were just choosing one. But I want you to write this in words. Write a verbal sentence to represent this. Take a minute, pause the video, come up with a sentence, and when you come back, I'll have a few here that you can compare yours to and see if it means the same thing. Okay, so here we have 3 different possible answers. There are so many more. So don't be worried if you didn't write exactly one of these 3 things. Chances are what you wrote is also correct, unless you just went way off the deep end into crazy town. Okay. 7 times a number minus 2 is 19. Is correct. So 7 times a number, remember, if you're writing it in words, don't write y, write it as a number. Okay, we don't want to put the letter name in here because it really is signifying a number, and we want that to come across. 7 times a number minus 2 is 19. That's pretty straightforward. You could write something a little more flowery that means the same thing. 2 less than the product of 7 and a number is 19. Also correct. Probably no one would say it that way, but as you saw in the earlier examples, sometimes they're written like that, and you have to know that that's what this is. You could also say 7 times a number decreased by 2 is equal to 19. Okay, so again, is equal to is fine. Is means the same thing. Decreased by is another way to say subtraction. That, I don't know, I guess it sounds better than minus, but it allows you to write it in the order that you see it. The whole less than business makes you reverse these 2 things when you write it in words. By saying 7 times a number decreased by 2, you have 7 times a number decreased by 2. You can write it in the order you see it. So that can be helpful. But again, I typically on problems like this allow pretty much anything that is correct, and there are so many ways to write it. So don't feel like you have to write exactly what I've written up here. You're probably good as long as you've got all the pieces you need. So, in this video you learned how to turn words into math and math back into words. And maybe you have a favorite. Maybe there's one you're better at and one you're not so good at. So, at the end of this section, which will be at the end of the next video, you'll have some problems to practice with. And maybe there's one way you really know well and another one you don't quite know so much. If you're having trouble on those problems, shoot me an email. Let me know. Come to my virtual office hours that I have Mondays and Wednesdays. And we will make sure you get it figured out. I love nothing more as I'm sitting at school, not teaching, than helping my students. And that includes you. So if you're shy and you think they'll think you're stupid if you don't know how to do this, trust me, this is not the easiest stuff in the world. This is tricky. So trust me, I won't think you're stupid. I encourage students to come to me with questions because being willing to do that is so much better in terms of you learning than you being too scared to ask and never learning anything. As your teacher, I want you to learn. And learning comes by asking questions. It's part of the process. So feel free to ask if you don't understand something, and we'll make sure that you get it. So, until the next video, we'll see you next time.